dependent events and probability. So here's the definition of dependent events. Dependent events are if the occurrence of one event affects the probability of the other. For example, we're going to look below here. There are 2 lemons and 1 lime in a bag. If you pull out 2 pieces of fruit, the probabilities change depending on the outcome of the first one. So what we have is a tree diagram here. So here's our bag. And there are 3 total fruits. 2 of them are lemons and 1 are lime. So when you first start off, you have a 2 out of 3 chance of getting a lemon and a 1 out of 3 chance of getting a lime. Now, we're going to go ahead and continue on with our tree diagram. Now, depending on if we get a lemon again or a lime. So when you move out, the chances get smaller. Now, look at this one. If we grabbed a lime and we tried to grab a lime again, it doesn't exist. So that's a 0. Now, if we grabbed a lime first, we have to grab a lemon next because there's only 2 lemons left. So the question here is, what happens if you try to draw out 2 lemons? So how we figure this out is we read the tree. We want 2 lemons. So we're going to multiply 2/3 and 1/2 together. So we get a probability of 1/3. 2/3 times 1/2 will give us a 1 in 3 chance of getting a yellow lemon and another yellow lemon. All right, replacement. The definition of replacement is, let's say you take a marble out and you replace it back again in the bag and you reuse it. Without replacement is the opposite. We don't replace it anymore. So there is a difference between when you talk about independent and dependent. So if you replace the marble back in the bag, then this is considered independent. The chances don't change. Now, if we have without replacement, so we don't replace it back in the bag, the marble, then these are dependent on each other, just like the lemon and the lime on the previous example. So let's go ahead and do a marble problem. So in our bag, there are 2 blue marbles and 3 red marbles. And we want to find out what are the chances of getting a blue marble. So just grabbing 1 time. Well, that's pretty easy. Probability of a blue marble, remember our sample space is 5. Well, we have 2 of them, right? So we have a 2 in 5 chance of getting a blue marble. Now, let's take the marble out and not replace it. What are the chances of getting a blue marble again? So we've created a tree diagram again. So you took the marble out, the blue one. Now, if you head off to grabbing a red or a blue here, there are only 2 blue marbles left in this case, or 1 blue marble. So it's going to depend on the other. And we're going to have a formula that we're going to use in just a little bit called conditional probability. All right, here's that tree diagram again. There's a 2 in 5 chance of pulling out the blue marble. That was the beginning. And you have a 3 in 5 chance. If we go a step further and grab that second marble, so now we're at the second marble, so the blue marble is gone. And we want a second blue marble. What we're going to do is we have to have a blue marble and another blue marble. We're going to multiply those numbers together. The probability of the first event, and then it decreases because we've already taken a blue marble out. And we multiply it again. So we have a 2 in 20, or 1/10 possibility of getting 2 blue marbles on the first chance and the second chance.